In the previous video, I explained how to study and how to solve problem 3. The problem 3 is basic and very important problem for our final examination, also for the understanding the neural network. So to understand this problem, please refer to this video, okay? This video for final examination, problem 3. And let's go to problem 4 for our final examination. Before that, so this is the problem 4. Before that, problem 4 and 5 and our final project are all related to this fundamental code, as you see from the screen, okay? This much. This code is the most vital to understand XOR neural network. So let me just briefly emphasize how problem 4 and problem 5 are related to this Python code. So from problem 3, we studied how Y is WH, and then when we know when H is 4, and then find W so that Y is 2. Then everybody know that this is very easy because since H is 4, and so this is H is 4, and now Y is 2, then W must be what? 0.5, okay? 0.5 times 4 equal 2. So that to solve this one, we start from the starting this one by gradient descent method. We are approaching the answer 0.5 using gradient descent method. So this problem is a little bit related to problem 3 and 4, 4 and 5, right? So for this one, this code is for XOR neural network. So XOR, there the input is the true and false. So two-dimensional vector is an input from this one. So input is two-dimensional. And then there is hidden layer. Also, this is two-dimensional, H1 and H2. And finally, the output is one-dimensional, true or false. So anyway, this one is related to this one. So from two-dimensional to two-dimensional, the matrix M1 is used to describe this correspondence. So this matrix M1 is this one. And from the hidden layer to, so let this be X denote the input vector, H denotes the hidden layer vector, and then from two-dimensional to the one-dimensional, we use M2 matrix from to describe the correspondence between H and our output, okay? Let this be output be Y. Y or letter O is used to describe, to denote the output. So M2 is this one, okay? So from the input vector X, we can get H. So from here, you get this one. In this case, in neural network, sometimes the sigmoid function is very useful. This kind of function is called activation function because our XOR neural networks are a true-false problem. true is 1 and false is 0. So sometimes it's useful to restrict our attention to the value between 0 and 1. Then sigmoid function is the sigmoid function, the graph of sigmoid function is the y value is between 0 and 1, the sigmoid. Sigmoid function is use this kind of sigma. The minimum possible value is 0 and maximum possible value is 1. So since we are dealing with true value and false value, sometimes sigmoid function is useful to uh, save time and give more efficient calculation. So let once the input vector is transformed to M1, after that, take sigmoid one more time. Okay, sigmoid. M1x dot this one, the sigmoid, let this be H. So H is so M on X and then taking sigmoid value like this. Okay. Also, the M2H after that, taking sigmoid, let this be Y. Okay. Let this go. Sometimes Y hat or Y or O, we use many different letters to represent the same output. Then, since this is output, but there is always a true value. Okay, for example, if x is true and false like this true and false, this is a column vector like. Then the true output must be true. T is true, but from matrix M1 and M2, our predicted value y may be different from the true value. So let the error is y minus t, may be the error. So y is an output by this kind of calculation, and t and true value, this is the we know the true value, okay? And then mean squared error is the square of this one, and then the sum divided by number of data. So in X or neural network, there are 4 types of input vector, okay? Because true, true, false, false, true, false, false. So there are 4 possible input vector, okay? So there are the number is 4. There are 4 types of input vector, or there are 4 many true value. Okay, and then since we are using currently for the current matrix M1 and M2, you can calculate mean squared error by this kind of calculation. Then let's save mean squared error in the list, mean squared error list. So mean squared error list, we put this value. Then please memorize this part. And then the problem 3 and problem 4 and problem 5 are related to the finding M2 and M1. So this is problem 4 and this is problem 5. Okay. So the problem 4 is how to find out M2. Problem 5 is how to find out M1. And then let this be E, and E. Let's introduce this kind of variable. This is 2 times ERR times y minus 1 minus y. So y is there. ERR is given this one. So you can find out this one. So in this case, the asterisk is a multiplication. So for example, when you have a vector 1 times 2 times 3 times 4, then this is the multiplication. How much multiplication? Then the value is the first component multiplied. So this is 1 by 3. And then second term is multiplied like this. So in general, this one is 3 times 8, okay? So the asterisk is a multiplication table, multiplication table operation. So using this one, we can find out EEE, and then DW2. DW2 is EEE dot product H transpose. So in this case, this H is a column vector. So as you see from this, H is a column vector, and M2 a is a 1 by 2 matrix, 1 by 2 matrix. So M2 is 1 by 2 matrix like this. Mm, So anyway, so this one is DW2 is H transpose EE times H transpose divided by norm. So I will explain this one in problem 4. Okay. Let's define ERR. Once you find out E, let's find out the dot product of this one and this one, and followed by there is another multiplication, H and 1 minus H. Then once you get ERR, DW1 is ERR dot product X transpose norm. So there is a kind of a pattern. This X, so ERR X transpose divided by norm. They are the same. But once you find out DW2 from here, from the given alpha is a learning rate, DW2, then you can get the new updated update the M2 matrix. Okay, so by gradient descent method, the matrix M2 is updated every time, and then gradually the this updation go to the desirable solution. And then DW1 is ERR dot product X transpose divided by norm, the DW1. Then from this one, DW1, you can get updated M1 value. Okay? So this is the fundamental, and this is the uh, main algorithm for the AI code of XOR matrix, XOR neural network. Okay, this one. So you must memorize this Python. So the problem 4, there are three possible sub-problem. The first sub-problem is I changed the order so that you can study more easily. The first sub-problem is the proof the derivative of the sigmoid function. From this one, the derivative of sigmoid function is this one times this one. Yeah. Please study this YouTube. Okay, this is very nice explanation. The explanation is based on this kind of mathematical computation. The second sub-problem of the problem 4 is what if problem. So for the following XOR code. So now you have this kind of XOR code, okay? We already studied this much from this code, okay? But there is a more code to denote X, the input vector, and true value, and running rate, also iteration. Also, we define a sigmoid function like this. Then from this Python code, we may ask, what is the shape of X transpose? So X transpose is this one, okay? So X is already. So X is from here, origin. So originally, 0, 0, the first row vector, second row vector, and third row vector. 1, 1 is this vector. Let this be, and then the x-axis, this one transpose. So this one transpose means the first row vector become the first column vector. And then once the second row become a second column, 1, 0, 1, 0, 1 is now third, 0, 0, this one. So X is in fact 2 by 4 matrix. 2 by 4. But our question is X transpose. So X is this one. So X transpose is what? So 1, 0, 0, 1, 1, 1 transpose. This one just return to original position because the first column become the first row, and this one is 1, 0, 0, 1, 1, 1. So now this one is the original, okay, original. So X transpose is now 4 by 2 matrix, 4 by 2 matrix. So the solution is our what if question. We ask what is the shape of X transpose? Then that is 2 by 4 matrix, 2 by 4 matrix. Let me quickly, let's execute this one. Then let's see. Okay. This one now exceed this one. Let's use print X transpose X. So you use print command to check the answer, okay? The X transpose shape. So when you execute this one, then this code will print out X transpose shape. Let's execute this one. Then what do you have? Okay, from here. Okay, this one. X transpose 1. The shape of this one is 4, 2. That is 4 by 2 matrix. So sometimes this one, it's better to write a shape in front of X transpose so that we can read. So from here, sometimes let this be shape of X transpose, okay? Then execute this one, then get this. Okay. It's more easy to read from here. Let's see. The shape of X transpose is 4 by 2. In this way, you may write down print command before what you want to know the shape of the variable, and you can get this kind of information. And anyway, the question is, what is the shape of X transpose? The shape means how many rows and how many columns. So, usually that is 2 by 4 and 4 by 2, something like that. Then what is the shape of H and 1 minus H? From here, you get H is there, okay, H is there. And then what is the shape of this one? Then this one is very easy because M1 is a 2 by 2 matrix. Then what is X? X is what? X is 0, 0, 1, 0, 0, 1, 1, 1. So that is 2 by 4 matrix, okay? So then what is the result? This one is just see the first and last one, then there is the result is 2 by 4 matrix. So H is 2 by 4 matrix, 2 by 4 matrix, and then H, this is the multiplication. The size is the same, 1 minus y. So, and then, so 1 minus y means if suppose y is 1, 2, 3, 4 like this, and then 1 minus 1, this one is term-wise, okay? 1 minus 1 is 0. 1 minus 2 is what? That is minus 1. 1 minus 3 is minus 2. 1 minus 4 is minus 3. So 1 minus, uh, so if y is 1, 2, 3, 4, 1 minus y is 0, minus 1, minus 2, minus 3, like this. Okay. Now H is 2 by 4 matrix. H is 2 by 4, and then 1 minus H is also 2 by 4. And that is a multiplication, not dot product. Multiplication is this term, this one is by the same position, just multiply this one. So the result is 2 by 4 matrix. So the shape of this one is 2 by 4 matrix. Likewise, once you understand this code and try to see the size of each object, okay? What is the size of this one and E, D, W, something like that. So from this code, this problem is just ask the size of the uh, object in this Python code. What is the size of ERR? What is the size of DW2? Something like that. So then by just computation or just using this kind of code, so there is some explanations there. Study this one to give an answer to this question. What if question? What is the shape of ERR? What is the shape of DW and DW2? And that is the second sub problem of problem 4. Also, the last sub problem of problem 4 is now find out M2, the second matrix. And in this case, until now, we use y minus t. So t is the true value, and this is the predicted value. But as I emphasized many times, many people use different notation like this. T minus O. So O is output. So this is output. So this output means predicted value. So in fact, this one is T minus 1. Just reverse of this one, okay? T minus 1. So sometimes many people use this ERR, T minus O, instead of Y minus T. So this problem is just consider the case ERR is T minus Y. T minus Y or T minus O, and try to find out M2. And then there is an answer. Answer from this one. So we want to find out W1, W2, W4, this one is M1, and W5, W6, this is M2. Our problem to find out M2 for a moment, okay? Then, To find out the matrix of M2 by gradient descent method, M2 is so 1 by 2 matrix. So this is W5 and W6. This is the M2 matrix. Then by gradient descent method, to find out the true value of this one, you must uh, calculate the derivative with respect to this variable. And then our goal is to minimize mean squared error. So as the mean squared error is decreased to zero, then true value and y value is the same, must be the same. So our goal is to minimize this mean squared error. Then mean squared error, there is a division by n. So for a moment, just consider the simple form, c, t minus o, the square, okay? But we will introduce divide by the number of n in the last calculation. So to more easy computation, for a moment, let's disregard this kind of division, and then just uh, take this division at the last step in our computation. Okay. So let this be CB, just ERR, ERR. Okay. In this case, ERR is T minus O, T minus O. So this is T minus O divided by this square, DW5. Okay. So this is using this one. And then this is T minus, so 2 times T minus 0, this 1. And also, what is O? O is output. Output is what? Sigmoid of yeah, output value is M2 H something like that. Okay, this one. So this output is related to this M2. There is W5 over there. So anyway, so let's see this one. To find out this one, uh, derivative of C with respect to W5, then you can get this kind of chain. The first one and second one and third one, okay? And then the first of all, from using this one, this is, we want to find out this one, but there is a 3, decomposition is possible. So first of all, this one is W5. We just find out the derivative with respect to O1. O1, this O1, and T minus O1, 0 is the derivative of DO. D is T minus O. Let's just disregard O. Just read 2 times. This is minus O. The derivative of this one is minus 1 over there. Okay, you can find out this one. Also this one and this one by one. Just check this one, okay? Check this kind of thing, and you can get the answer. So in this way, now we solve the problem 4.1, 4.2, and 4.3. Let's go to problem 5. The problem 5, there are 2 sub-problems. The first one is to find out M1. So the M1 matrix, there are 4 elements. Okay, so M1 is the matrix from the input vector and the hidden vector. Then W1, W2, W3, W4. There are 4 numbers inside of this, the matrix M1. Okay. The problem 5.1 is to find out this matrix, okay, and explain the case ER is T minus O. By the same method, this is the answer. Let's find out the derivative of C with respect to variable. So for example, the first variable, W1, let's consider this one. And then please memorize this one by the chain rule. As I said before, you may cancel this way. This one is equal to this one, so cancel out this one. But that is not a mathematical explanation. But intuitively, you can use this kind of, oh, this one is canceled out, canceled out. Then finally, the round DC is remained, and in the denominator, dW1 is remained originally. So they are equal. But this is the calculus problem, so I don't want to prove this one, this chain rule, but using this kind of decomposition, there are 5 decomposition. So each this kind of blue and red decomposition, there are 3 blue part and 2 red part. Then from each, you can calculate this kind of computation, and then this one is, so this dW1 is ERR dot X transpose N, and then using this kind of thing, you can get the first matrix M1. So in this way, you can solve the first part of the problem 5. Now, there is some more detailed explanation is followed. The second part of the problem 5 is the visualizing process. So as times go, as you execute XOR code again and again, then the accuracy will be improved. Then how to show that your calculation improve the accuracy? Then you must show that the mean squared error is decreasing. There is approaching 0. Okay? Mean squared error is going to 0 means the predicted value is equal to true value. So it's nice to introduce a kind of this kind of the graph for mean squared error as times go, as execution number increase, just show that the mean squared error is decreased. Then the problem 5, the second part, the last problem, 5.2 is how to check the accuracy. Write down the code for this purpose. So how to show that your Python code is working, so that as times go by execution again and again, this Python code improve the accuracy by showing that the graph of mean squared error is look like this, approach 0. Okay? And then finally, just compare. So like this. The prediction is like this one or this one. So usually now this is 0.3, and then the true value is 0. 0.93, the true value is 1. 0.93 is 1. 0.1 is 0. So it's almost equal to the true value. Okay. So there are 2 kinds of way to show the this code execute and this code improve as execution goes, by showing that the output value is very similar to the true value, or using the graph of the mean squared error. There are 2 methods, 2 ways. The first one is like this one. This blue code make this kind of black, the correspondence surrounded by black dots. And then this blue code just show the shape of the mean squared error curve as epoch increase. So that is the uh, uh, final problem for our final examination. Okay. So anyway, the final examination problem for the end. So the answer to the second part of problem 5 is this code. Okay. So as you see the answer, and then you may memorize this Python code. So each problem you can find out this kind of answer explanation. Just study answer part. And from this one, there is an answer part. Just study this one to answer the problem. The first solve problem 5. Let's go to problem 4.3. 4.3 also there is an answer. Then study this equation. And then how about 4.2? The 4.2 is the second sub-problem of problem 4 is what? Just this is the problem, okay? There are lots of problem to ask the shape of the object in the Python code, and then there is some explanation. Then just try to give answer to each black and blue what if question to prepare the second part of the problem 4. And finally, the first sub-problem of problem 4 is to just write down the proof that the derivative of sigma x is sigma x times 1 minus sigma x. So in this way, you can study problem 4 and 5 to prepare for the final examination. So in the final examination, there are uh, problem 3 will be our first problem. The second problem is problem 4, sub-problem. Third one is problem 4. Fourth problem is problem 4. Third. The problem 5 is now that there are two sub-problems. One, and the sixth one is the problem 5, 2. Okay. So the maximum possible score is the problem 3. There is the code one is 6 plus 4. Total 10 points. Problem 4.1 is that is the proof of the sigmoid function, and this is 7. Problem 4.2 is that this is a kind of what if ask the question for the shape of the function. This one is now 6, and this one is what? I forgot. It may be 8, or this may be 7. So anyway, the total of problem 5 is 15. The total of the problem 4 is 25, 20. Let's see. Okay. And then the first one is, oh, sorry. That is not, this is 7 plus 8. 15. Problem 15. So 15 plus 20, the total score is 50 points. And for the final examination. So just equal to this kind of thing. From 4, 776 points. The first subproblem, second subproblem, and third subproblem. So it's enough to study problem 3 and 4 and 5 to prepare our incoming examination. Okay. On next Monday, there will be a quiz. The quiz problem is to memorize this code. Okay. You must memorize this Python code. I already sent this one using the WhatsApp. So the Monday quiz time, I ask you to memorize this one and write down your memorized code to the paper, okay? And then take a picture using Subway using WhatsApp. WhatsApp. Okay, thank you very much. And please study this one during the weekend to prepare the incoming uh, final examination.